Hello out there, welcome to this tutorial on sequences and series. In this video, we'll be expressing sigma notation as geometric series. So we start with our first problem. Problem 1. Calculate sigma n equal to 1 to 10, 3 times 2 raised to power n minus 1. The meaning of this is we are to sum up 3 times 2 raised to power n minus 1 for n equal to 1 up till n equal to 10. So in our solution to this problem, we take 3 times 2 raised to power n minus 1, and then when n is equal to 1, we are going to have 3 times 2 raised to power 1 minus 1. This is 3 times 2 raised to power 0, and 2 raised to power 0 is 1, multiplied by 3 gives 3. So the first term of the series is 3, then plus we take when n is equal to 2, that's going to give us 3 times 2 raised to power 2 minus 1, and 2 minus 1 gives 1. So we have 3 times 2 raised to power 1. 3 times 2 raised to power 1 gives 6. So the next term of the series is 6. Then plus, we now use when n is equal to 3. This is 3 times 2 raised to power 3 minus 1. This is giving us 3 times 2 raised to power 2. Since 3 minus 1 is 2. 2 raised to power 2 gives 4. 4 times 3 gives 12. So the next term of the series is 12. Then plus, we may not be able to list all the terms of the series. So we put dot 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 plus the last term, that is when n is equal to 10. So 3 times 2 raised to power 10 minus 1, that's giving us 3 times 2 raised to power 9. 10 minus 1 is 9. 2 raised to power 9 is 512. Multiplied by 3 gives 1553. So that's the last term of the geometric series. Then we are done. We then go ahead to get the formula for summing up geometric series. So we have two of such formulae. We have Sn equal to A into 1 minus r raised to power n over 1 minus r. In this case, it is when r is less than 1. For here, Sn is equal to A into r raised to power n minus 1 over r minus 1. This is when r is greater than 1. So we get our first term to be 3. The common ratio, that is 6 divided by 3 gives 2, or 12 divided by 3 gives 2. And our n is 10. So this 10 here. Since our r is greater than 1, we are going to make use of the second. So the sum of the series up till 10 terms will be our a, which is 3, into 2, then raised to power 10. Since our n is 10, then minus 1 over 2 minus 1. And 2 raised to power 10 is 1024, minus 1 gives 1023. So we have 3 times 1023 divided by 1. Simplifying the numerator, we have it as 3069. And that's all for the solution of problem 1. We then go to problem 2. For problem 2, calculate sigma n equal to 1 raised to power 15, 3 raised to power 5 minus n. Again, in our solution to this problem, we are going to be summing up 3 raised to power 5 minus n from n equal to 1 to 15. So generating the series, we look at when n is equal to 1. That is 3 raised to power 5 minus 1, giving us 3 raised to power 4. And 3 raised to power 4 is 81. So the first term of the series is 81, plus the next term when n is equal to 2. That's giving us 3 raised to power 5 minus 2. 3 raised to power 5 minus 2 gives 3 raised to power 3. And 3 raised to power 3 is 27. So we have the second term to be 27 plus the third term, that is when n is equal to 3. That's giving us 3 raised to power 5 minus 3, giving us 3 raised to power 2. And 3 raised to power 2 is 9. So the third term is 9 plus, since we may not be able to list out all the terms of the series, we put dot 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 plus the last term, which is when n is equal to 15. That's giving us 3 raised to power 5 minus 15, giving us 3 raised to power negative 10. If we say we are going to simplify this, it will be too large, so we leave it in index form. That's giving us 3 raised to power negative 10. So we then consider our formulae again. Before then, we get our first term to be 81. Our common ratio, that's going to be 27 divided by 81, which is 1 over 3. And our n is 15, since it is from 1 to 15. And here our r is less than 1. So we're going to make use of the first formula. So we have S15 will be equal to our A is 81, and then into 1 minus our R is 1 over 3 raised to the power 15. We close the bracket, over 1 minus our R, which is 1 over 3. We can input this in our calculator. We input it in our calculator, giving us 81 times open bracket 1 minus 1 over 3 raised to the power 15 in bracket, close the bracket, over 1 minus 1 over 3. You hit the equality or the enter button. We have 121.499999, which is approximately 121.5. And that's all for the solution of problem 2. And this is the highest we can take in this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.